Hi everyone, welcome back to our YouTube channel. I am Desire, and today I've got Luciano, who has just completed the course Linux Basics, and he'll be giving us a presentation about that. So first of all, we'll see a demonstration of his code base running on the real robot as usual, and then we'll get into the details about his project and how we managed to do the required tasks. So I'll now hand over the floor to him so he can begin his presentation. All right, whenever you're ready, Luciano.
Okay. Well, first of all, thank you, Desire, for your time. My name is Luciano. I'm going to show you what I just learned from the course Linux Basics for Real Robots. Well, here, as you can see, it's a short program where I can control a robot inside a tiny area. So first, before explaining my program, I would like to connect to a real robot. So if it is okay, I'm going to proceed to connect to the Robot 3.
Yes, let's go ahead.
So here goes. Well, while it is connecting, I would like to explain a bit about my program.
Okay.
It's a straightforward one. What it does is to measure the robot around it. You will see where there is enough free space to move. If it is free in its front or in its side.
Okay, all right.
Then it will take make a decision and execute the decision if you have to move forward or have to turn to its right or its left.
Okay.
Here we have the real robot, the type of free. Then I'm going to execute my program. Just a second.
Okay. Okay, we can see it moving.
Well, here in this shell, we can see the program running. We can see its evaluation where there is a free space. If it has free space in its left, in its front, or in its right.
Yes.
And according to that, it will be moving.
Okay.
Here we have the real robot, and well, something that I don't like about the program is that it's make really short movements in each decision. So this is something that I would like to enhance in the future. But for this presentation, I think that it is okay. As you can see it here, you can see the decision that the program takes. If here it turns 90 degrees to its left, then 90 degrees to its right. All of this decision is according to the free space that the robot has in its surrounding.
Okay. Okay.
So, if it is okay, I would like to show you now my program running in the simulation.
Can you just have your robot start from a different place? Because right now it has not moved. It just seems to be trying to avoid obstacles, right? It's trying to get out of the corner. So
yes. Well, I'm going to kill the program.
So I think you must kill it and then move the robot using the joystick or your tele-op keyboard to a different place and then try running it from there again.
Okay. That's fine. Here. Let's kill this too. Then go. Okay.
Okay, let's have it start from there and see.
Hi. Okay. Let's run it again.
Okay.
Face.
Okay, there we go. It's moving.
There it is. Yes. The program first make a measurement about the robot's surrounding, and well, it's decide if to turn to its left, its right, or move forward. Then execute that action and repeat all the process again. It's a really easy one. There's not much complication in there.
I like the fact that it shows the direction in which it's facing. I'd love to see how you managed to do that. Okay, there we go.
I love that I can enhance the program.
Yeah, I think
for the presentation, it's enough, I think.
Yeah, it's alright. I think it's probably checking the sector that it's checking to consider if it's far from the obstacle might probably be too wide. So instead of checking just maybe 90 degrees or 45, let's just say 90 degrees to the left or to the right, it seems to be considering more than that. Okay, you see. So I guess, yeah, it was supposed to just start moving forward because there wouldn't be anything. But it's fine. It's perfect. Let's go to the simulation version and see it running simulation. I think it will stop
Okay,
just facing the wall now.
let me kill the process.
Mm-hmm.
I'm going to disconnect from the robot.
Okay.
Now I'm going to connect to the simulation.
Okay.
Nope. Well, it's the same program
Mm-hmm.
as the one you saw in the real robot,
Okay.
now running on the simulation.
All right.
And I don't know what.
Base.
Why. I don't know what's there. You haven't found the command?
I've got all the ROS interface running.
Or
Okay.
I
Let's see.
have running the interface?
I think, okay, try killing your naive obstacle
Okay.
avoidance script and then running it again. Let's see. And try running it again. Okay, so it's parameter successful. Okay.
Mm-hmm.
Can you go and refresh gazebo? Just on the top, on the very top, on the right, on your gazebo window.
Would you like me to kill the gazebo?
Yeah, maybe kill it and restart it again. Let's see.
Okay, let's go again. Okay. Ah, sorry, sorry.
All right. Okay. Let me see if we still have any more time. Okay, we've got 3 minutes. I think.
There it goes.
Okay, that's better. Okay.
The real one here, we can see the simulation working the same.
Yeah. Okay, that's good. Okay, I think while this one is just leave this one running, can we go through your code and you explain what you did?
Maybe I can do this. I can leave it here where I explain the code.
Yeah, it's
So
alright.
we can see the simulation.
Yeah, okay. Alright, so take us through what you did, how you did it, and give us the why you chose to implement it that way.
Okay. Well, here I'm importing, including the file robot function with all the functions that um, it's I use in my program.
Mm-hmm.
Here I get the value of the different variables
Mm-hmm.
and set the new ones.
Okay.
Um, Here I execute the these two functions. I set the robot to an initial state
Mm-hmm.
in a linear and angular velocity to 0.
Yes.
And here is my variable, my constant, where the program is in each cycle comparing if it has enough space to move or not.
Mm-hmm.
Here is the main part of the program. It's the while cycle. Uh, Here is the process that it will repeat again and again. Uh, it will first get the value of the robot around it.
Mm-hmm.
It will get its left, its front left, front right, and right space. And saving that value to this variable. Then here it will compare if that space is enough to consider that you have free space.
Okay.
And it will be comparing with the concept that I created at the beginning of the program,
Okay.
the code.
You've got 2 more minutes.
Okay. And then when you have when the program has taken the decision, it will execute it. If it has more space in the left than in the right, it turns to the left.
Okay.
Or to the right. Or if it has more, it has free space. Yeah, if you don't, sorry, the left it has no free space, and in front it's not free, and the right is not free. Is free, sorry. It will turn to its right because you have a free space in the right.
Okay.
You are calling the method, and you are passing the value to as a parameter. Then it will set to 0 to stop the movement.
Okay.
Well, this logic will repeat in several sentences, comparing what the program has measured, what the robot in fact has measured. And at the end, it will repeat the whole process again.
Okay. All right. Did you want to say something?
I don't know if. Sorry?
I said, did you wanted to say something? I think we are out of time now.
Sorry. Well, I hope that I could get across on my program, and well, I would like to thank you and the construct for this opportunity to learn a bit about all the robot development work. Well,
all right.
Again, thank you.
It is our pleasure. Okay, let me ask you a couple of questions now. So, these are gonna be mostly about Linux and the using the base scripts and the command line, right? The terminal. So, can you just within the context of what we've been talking about, can you give me a brief explanation of why we need base scripts, right? Particularly within the context of robotics. Why are they important?
Sorry, can you repeat the question again?
The general purpose of bash scripts, right? So you had to create a bash script in this project, right? From your understanding, what is the main purpose of having bash scripts?
It's because all the software we make in order to control robots are most of them basically are made in Python. Bash script, it's a document where you can list all the commands that you can execute in a shell.
Okay, all right.
All the commands you put inside a bash script, you can execute them in the shell and
true.
in the other way.
All right.
So here you can list all the commands you want to execute and just execute the shell script. It's a way to
combine all of
the
them.
best way to
and execute
Yes.
all of them. All right, I understand. Okay. Then going on to now more general questions, right? So if you do have to give files permission to execute, right? Can you give me a couple of ways that you can do that? How do you give permission to files for execution to allow them to execute?
Well, code execution, you make it by the shell. You execute the command chmod,
Mm-hmm.
and with that you can give the permission to read, to write, and execute the command.
Mm-hmm. All right.
You can use characters in order to give the file the permissions,
Mm-hmm.
or you can use it with numbers.
Okay. All right.
And then you can check if the file has permission using the ls.la command.
Right.
I
Okay.
think that I used recently here.
Okay. Yes. Yes. I understand. Well done on that. I like that. Now just for the last question, can you give me the general difference between Control C and the kill command, right? So what is the difference between those?
Control C and the kill command. Well, with
Yes.
Control C, you are killing the program that is executing in the shell. That is um, in that you are seeing in the shell. You are seeing it executing in the shell.
Mm-hmm.
While when you kill a program, it's when you want to kill a program that is running in the background.
Okay. All right. All right.
So, but in order to kill a program, you need to know the PID of that process.
That's correct. That's correct. I want to know a little bit more in terms of which one of the commands gives the program a choice to terminate the way it wants, or does it give it an option, right? Because there are differences in with regards to that.
Sorry, can you repeat again, please?
So normally one of them, either Control C or Kill, forces the program to terminate, right? Whereas the other one gives it a choice of how it's going to terminate, or maybe even not terminate.
When you can pause the process, right? You can put the process in the background and stop them for a while.
All right, all right. I do understand. Anyway, to just wrap up, the general context I was looking for here is that normally when you use Control C, right, you give the executing program an option to maybe not terminate, right? Whereas with kill command, you are generally telling the whole process to forcefully terminate. So, but anyway, it's alright. I like your way of describing the way the process is okay, even though you didn't really get to
I'm sorry
what I was finding.
not to answer that last question. Sorry.
No, it's alright. It's alright. Anyway, let's wrap it up here, and then we'll finish our conversation on Zoom. Okay. Alright, everyone. So this was Luciano's presentation, and we would like to encourage all those of you who would want to try the courses over certification on to do so, and then you can come and give your presentation. So until